Let's look at this first one, A. Notice we have a 3 to the 1/2 times another 3 to the 1/3. Well, notice the base is the same on these. They both have a base of 3. So their base, when we multiply, will stay the same. It will stay as a base of 3. The question becomes, though, what do we do to the two exponents? Well, we have an exponent of 1/2 and an exponent of 1/3. When you're multiplying, what do you do to your exponents? You add them. So we need to add 1/2 and 1/3. Well, how do you add two fractions? Well, you have to have a common denominator. So what is a common denominator for 2 and 3? Well, that would be a common denominator of 6. Well, the first fraction to get the common denominator of 6 is going to get multiplied by 3, which will give me 3/6. The second fraction has a 3, so to turn it into a 6 would be to multiply the top and the bottom by a 2, which would get me 2/6. So once we have a common denominator, we can add or subtract normally. Or 3/6 plus 2/6 gets me 5/6. So that means that that is my exponent, not my final answer. The base was 3 because the base stayed the same. My new exponent, because I'm adding my exponent, is 5/6. So that's my final answer, 3 to the 5/6. Let's look at the next problem. Again, we have that we're multiplying and the bases are the same. The bases are both in x. So when I multiply, the base of x will stay the same. The question is, what's going to happen to those exponents, which is a 2/5 and a -1/3. Well, if I'm multiplying, remember that I'll add the exponent. So I'll take a 2/5 and add it to a -1/3. So if I'm adding two fractions, remember that I need a common denominator of, in this case, I need a common denominator of 15. Well, that first fraction has a 5 on the denominator, so it's going to need to get multiplied by a 3 on the top and the bottom, which will get me a 6 on the numerator. The second fraction already has a 3 on the bottom. It needs to get multiplied by a 5 to get the 15, which will give me a -5 on top. Now I have a common denominator, so I can go ahead and add. I've got a 6 plus a -5, which will give me 1 over my common denominator of 15. So that means that my final answer is, remember the base stayed the same, which was x, and my new exponent here is 1/15. So my final answer is x to the 1/15. Let's look at C. Notice we have, again, the same base of 7. So the base will stay the same. It'll be a 7. The question is, what do you do to your exponents? Well, we've got a 2/3 and a 4/3. So we're doing division, so we'll subtract the two exponents. So we've got 2/3 on top minus the exponent on the bottom, 4/3. Luckily, we already do have a common denominator when we're subtracting these two exponents. So we can go ahead and subtract normally, which will give us a -2/3. That means the exponent on my base of 7 after subtracting is a -2/3. The problem is I can't leave my answer like that because I don't like having negative exponents in my final answer. So the question becomes, how do I get rid of negative exponents? Well, as a reminder, we make them positive by dropping them to the denominator. So when I drop this down to the denominator, it becomes 7 to the +2/3. The Question is what's hidden up on top, and what's hidden up on top is just a hidden 1. And I can leave my answer just like that. The only other possible way to rewrite this is that we've got a 7 here. The 3 on the bottom would technically mean that we've got a cube root of, well, we also have a 2 on that fractional exponent, so of 7 squared, which technically means you could rewrite that 7 squared as a 49. So that would be possible to rewrite this as 1 over the cube root of 49. Either one of these answers are correct. It just depends on how far they want you to go in simplifying your result.